Hey class, this is the second part of our balancing equations video series, and in this video I'm going to explain why I didn't do number 9 and why I didn't do number 12 on the previous video. To do these, you need to know something called the doubling technique. I'm going to write that up here. And I'll explain what that means in just a second. So let's set this up just like we normally would. Line, silicone, hydrogen, oxygen. The doubling technique only ever comes into play when you have at least one diatomic element. In this case, it's oxygen. Let's count our silicone. Silicone is 2, hydrogen is 3, oxygen is 2. Over here, silicone is 1, oxygen is 2 plus 1, which is 3, and then hydrogen is just 2. So with our diatomic, we're going to save that for last. So let's balance silicone first. 2 over here, we need 2 on this side. So there's 2 of that. Changes oxygen. 2 times 2 is 4, plus 1 is 5. Okay, let's fix hydrogen. Can we ever make 2 and 3 balance with one move? No. We can make them balance at 6. So let's make each side 6. H3, to get to 6, we need a 2. But now we got to change silicone. 2 times 2 is 4. Go to this side. We're going to make this one 6 as well. 6 divided by 2, 3. Now that's balanced. 3 times 1 is 3. 2 times 2 is 4 is 7. But we threw silicone out of balance. So now we got to go back and fix that. The only place we have silicone is right here, so we're going to have to change that coefficient. To make it a 4, we're going to have to put a 4. But now we got to change oxygen again. 4 times 2 is 8. 3 times 1 is 3. 8 plus 3 is 11. So now we're good here, but not on oxygen. Now, the problem is, can you ever make an O2 equal an odd number? No. So if this is the only source of an element on one side or the other is a diatomic, the other side has to be even in order for that equation to be balanced. So this will never work the way it is now. Now the doubling technique, where that comes in, you're going to double every coefficient you have, because when you double something, when you multiply by 2, you're always going to get an even number. So multiply every coefficient by 2, except your diatomic, because you don't know what that is yet. So this 2 now becomes a 4. This 4 now becomes an 8. And this 3 now becomes a 6. Now we're going to go back and recalculate everything. 4 times 2 silicones is 8. 4 times 3 hydrogens is 12. Leave oxygen alone. Over here, 8 times 1, 8. Good on those. Hydrogen, 6 times 2, 12. Good on that too. Now we got to calculate our total oxygen for the product side. 8 times 2 is 16. 6 times 1 is 6. 6 plus 16 is 22. Now we can make this diatomic come out to 22 by just putting an 11 there. That's why it's called the doubling technique. You have to double everything. Let's do one more. And oftentimes you'll get some very large numbers while doing this technique. But as long as you can't reduce, it's all fine. All right, we've got FeS and O. Iron, we got 1 on this side. Sulfur, we got 2 on this side. Oxygen, we got 2. Oxygen's going to be our wild card. Iron is 2 over here. Sulfur is 1. Oxygen, 3 plus 2 is 5. All right, so we're going to save oxygen for last. Let's worry about iron. To make this 2, simply put a 2 right there. That's going to also change sulfur though, so 2 times 2 is 4. All right, go to this side. We want to make sulfur 4. It's a 1, so we're going to add a coefficient of 4. So that makes sulfur 4, but it's going to change oxygen to 4 times 2 is 8, plus 3 is 11. There's that stinky odd number again. Everything's balanced except oxygen, and oxygen's a diatomic. That's the qualifications or the indicator that you need to do the doubling technique. If everything in your entire equation is balanced except for one diatomic element, that's when you need to use the doubling technique. Take this 2, make it a 4. Leave that alone. This is technically a 1. So now we're going to make it a 2. Make this 4, an 8. Let's go back and recalculate. 4 irons, 4 times 2 sulfurs. Not worried about oxygen. 2 times 2 is 4 irons. 8 times 1, 8 sulfur. And then for our oxygen count, we've got 2 times 3, which is 6. And then 8 times 2, which is 16. Add those together, you get 22. Now you can finish your equation out with 22 divided by 2 gives you 11. If you have any problems with this, or if you run into it in either a classwork or a quiz, and you're struggling, let me know, because this is a very important technique, especially when we get to more complex equations moving forward into stoichiometry, gas laws, and solutions. I hope this helps.